Hello everybody and welcome back. Now we're going to work on area. So on the back of 10A, there's just notes. That's all it is. It's just notes to work on the following assignments. So that's why we did this in class. I graded it real quick and I gave this back to you. So what we're going to do now is I'm just going to explain this just to make sure everybody understands what's on here. So I've got my first one is a triangle. Now a triangle can be drawn a couple different ways. We're going to go with two standard versions. Okay? Now I made this a dotted line because there's not actually a line here. It is just a hypothetical line. It is letting me know that from here to the top is the height of my triangle. And I'll mark it with a 90-degree angle just like I did here. So here's my 90-degree angle. And this is my height. Okay? Now over here, this is also my height. And the entire thing is my base on both triangles. Now, no matter which one you're looking at, the formula for the area of a triangle is always going to be 1/2 times base times height. No matter what numbers I give you, it's always going to be 1/2 times base times height. And that is the base of the triangle, no matter which one it is, and the height to the peak of the triangle. Okay? So you'll level one side out, even if it's a cockeyed triangle. So even if it looks like this, and it's kind of crazy, you would just turn it around and still find the height. Okay? There's a little glare right there. So even if it was like this, I would just kind of rotate it around, which we'll go over later specifically. But I would still just find a flat side and find the base to the top. And that's my height. And then I would still do it the exact same way. So that's for a triangle. Next, for a square or a rectangle, so remember a square, all the sides are the same. A rectangle, there's two short sides and two long sides. The formula for area for both of these, though, is still base times height. And it still means that this is my base down here on the bottom, and this is my height. Now, it doesn't matter if it's actually on the bottom, because a square, every side is the same anyway. So as long as you took one side times another side, and it's a square, then it doesn't matter. Now for a rectangle, you'd have to take a short side times a long side. You couldn't just go across. Because what you're doing is, inside, you're making tiny little squares. And we're going to call them 1-unit squares. And it's going all the way across. And then this way. Alright? So hypothetically, I made 1, 2, 3, 4, 5, 6. Because I'm actually counting each individual square. So I've got 6 high. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 long. So I'm counting each individual one. So really, if I break these down, this is a 1 by 1 square. So I'm adding all of those together. And the way that I can add all those together is base times height. Because I'll have 11 across every single time if I drew straight. So we won't pay attention to the corner. And I'll have 6 down every single time. So I have 11 columns times 6 rows. Because each individual square is 1 by 1. So I'm just adding 1 plus 1 plus 1 plus 1. So it's like when I take 2 times 4. I'm multiplying 2 4 times, right? So this way, I'm just multiplying the rows times the columns. It's a little bit of better explanation for area of a square and rectangle, because it's the exact same thing over here. These numbers just happen all to be the same. If that confused you more, just always remember base times height is area. Base times height. Okay. Alright, next up is a trapezoid. Remember, a trapezoid has base 1 and base 2. It doesn't matter which one is which at all. I always just like to label my top one 1 and my bottom one 2. Just it makes it easier for me. And then this is our height. And again, this is a trapezoid. Okay? So this is a trapezoid, bottom and top. Now if I'm looking at this, the area for a trapezoid is 1/2 times the quantity. Remember, the quantity is everything inside the parentheses. Base 1 plus base 2 times the height. Alright, so if I'm breaking this down, I technically have 2 triangles and a rectangle, right? Or maybe a square, depending on how the numbers work out. So looking at it right now, it looks like I have 2 triangles plus a square. So that's why this formula looks somewhat similar to a triangle formula. But I literally would just add my bases together. So let's say I call this one 7, and this one's going to be 5, and then I'll label my height 4, just for giggles. So I'll have 1/2 times my first base, 5 plus my second base, 2, all times my height of 4. I'm going to do everything in the parentheses first. So I'll have 1/2 times 7 times 4. And then I can see this as 1 over 2 times 7 over 1 times 4 over 1. I multiply across. I get 28 over 2. I get 14. So look, all I did was plug in my first base, I plugged in my second base, and I plugged in my height. All I had to remember was this formula right here. So once you see the shape that you're looking at, so this is a trapezoid, and you know your formula, you just plug in whatever numbers I give you. Okay, so that's a trapezoid. Next up, I have a parallelogram. A parallelogram is like a tilted rectangle. This side is the same, and these sides are the same. This is a parallelogram. Okay? Now, and again, this is not 90 degrees. This is an angle. All of these are angles. These 2 angles are going to be the same, so we'll call these both A. And these 2 angles are going to be the same, so we'll call them both B. To find the area of the parallelogram, it's base times height. So this is my base, and this is my height, this imaginary line right here. Not the side, but the height of the inside to the top corner. Now you could do it on this side too, but just making that little triangle. So it's the base times the height, not side times side, base times height. Alright. Next up is a rhombus. A rhombus is a square tilted. So they're all the same sides, but I have little angles in here. This is going to be angle A, and these are going to be angle B. Alright? Now, for a rhombus, you actually go with the diagonals. So I'll label this A. Let's see how I do on here. A, B, C, and D. A to B right here is called a diagonal. Now this is on your worksheet too. It's this little section right here. So it's a diagonal, C to B. Now C to B is also a segment, so you write it like this, with the segment line on top. And A to D is a segment. and also a diagonal. Okay? So to figure out the area of a rhombus, and here's a rhombus, alright? And again, this is a square tilted. Again, all the sides are the same. But so to find my area for this, it's 1/2 AD times CB. And I know this looks kind of difficult, but it's not. You can absolutely do this. Okay, so if I was looking at this like this was a segment right here, just like back to our line segments, alright, it means that I would take this length, whatever it may be, times this length. So instead of doing the side times the base, I'm doing the inside lines, the inside diagonals right here. And these are diagonals. This is my formula. We'll practice with this a lot, but you just need to understand the concept that it's diagonal lines, and that's what you're multiplying. Next is a polygon. Again, a polygon is any shape with 3 or more sides that it's closed in. Okay, so polygon, I'll just throw in a hexagon just for giggles. So my hexagon has a center. Okay, so this is the center of my hexagon, or the center of whatever shape I so choose. So if I wanted to do a triangle, there's my center to the side. Alright. We already have them for a triangle, so we don't really need to do that. But for any shape, it doesn't matter if we already have anything on it, but for any shape, it would be 1/2 the apothem, APOTHEM, times the perimeter. Okay, so this is like high level area. You won't see this a whole lot, but you will see it, so you need to understand it. The apothem is this right here. Okay, so this is the center point to a side. That's all it is. The center of the polygon to any side. Alright? And the perimeter is the same thing that we've been doing the whole time. It's just the outside. So I'd have to add up all of these sides. So we'll call this 4, and we'll call this 2, 2, 2, 2, 2, and 2. So our apothem is equal to 4, and our perimeter is all of our sides combined. So I have 2 plus 2 plus 2 plus 2 plus 2 plus 2. So I have I have 12. So my perimeter is 12. So just like any other math problem now, 1/2 times 4 over 1, because any whole number is always over 1, times 12 over 1 equals 24. Alright? That's all there is to it, but you just have to remember this word here, apothem, and it's on here as well. So it's on the bottom with definitions and a little drawing. That's why I gave you this specifically right here before we do the next area problems. Alright, so that is all of our area shapes. We're good to go. See you in the next video. Busy days.